Kia ora, Year 11 and 12. This is a video for my 12 MAA class for what we're going to be doing on Monday, but hopefully some of you are going to watch it before then. We're going to learn how to use the quadratic formula to solve any quadratic equation. But we're not just going to get the formula falling from the sky, we're going to prove where it comes from. So this is the formula called the quadratic formula. I'm going to write it up first and then talk about what these B's and A's and C's are. So this is one where you'll get given this formula, but you should have used it so many times that you know it within the next couple of days. We can write any quadratic equation in this form: ax squared plus bx plus c equals 0. And we're going to do this over and over. So from now on, when you see a quadratic, I want you to think straight away about what's a, what's b, and what's c. And you know that we always write it in the order of descending powers. So if we had, for example, 3x squared plus 18x plus 8 equals 0, then we'd write down straight away a equals 3, b equals 18, and c equals 8. So if we get a quadratic equation, we still think about the easy ways to solve it. First we think about factorizing. Then we might think about completing the square. But we have a new tool to chuck into our toolbox, which is this lovely formula here. So I'm going to do this example, going straight to using the formula. Then I'm going to show you where the formula comes from. So what's x? Well, x is equal to negative b, so I'll write it out again, negative b plus or minus the square root of b squared minus 4ac. Now I try to make my students always write that out when they do one of these questions, no matter how long they've been using it for. It's really easy to muck up your negative signs. So x is equal to negative 18 plus or minus the square root of 18 squared minus 4 times 3 times 8 divided by 6. So let's have a look at what that boils down to. Well, we get negative 18 plus or minus the square root of, so 18 squared is 324 minus this bit here, so 12 eighths, which is 96. Now I know lots of you are going to do that straight into your calculator, and that's fine. Just be careful that you're taking the square root of all of this, not just of the 324, and then we're dividing that by 6. So if we work that through, we get x is equal to negative 18 over 6 plus or minus the square root of 228 divided by 6. Now you can do some simplifying stuff on this surd here, but I don't want to get sidetracked onto that in this video. So all I need you to do now is to grab your calculator and get a decimal approximation for this whole thing. And we end up with this: x is equal to negative 3 plus or minus this bit, which is 2.5166 ... Okay, and that gives me my two solutions: negative 5.52 or negative 0.48. Now we know what that means for graphing, by the way, and I want you always thinking about what the graph would look like. These are my two x-intercepts. So if we draw a bad graph, we know that the parabola is an up the right way one with intercepts here and here, so it's going to look something like that. Okay, the thing that's giving us two solutions is something we're going to focus on in later videos, but it's coming from this bit here. So the fact that I've got a plus or a minus and then a number here is generating the two solutions. Sometimes we won't get two solutions, we'll get one real solution or even no real solutions, but that's a video for probably later on in the weekend. So that's using the quadratic formula, right? So let's go over it. Here's my formula. I've taken my a, b and c values and I've basically just shoved them in and put it through my calculator. So let's look at where that might have come from and how else we could have solved that equation. So I'm going to go back to the equation to start with, and we're going to pretend that we've never seen the quadratic formula. Sorry about background noise, but it's Friday night and I can't really ask my kids to be quiet because that would be mean. So completing the square on this one, what would I do? Well, we've talked in class about how we don't like working with a 3 here if I'm going to have to complete the square. So we're going to divide through. Let me try and get the nice sparkly pen that some of you like. There's x squared plus 6x plus 8/3 equals 0. So that would be my first step, because now I've got a nice easy quadratic to do completing the square on. And even better, I've got an even number here. So if you're in my class, you'll hopefully be getting used to drawing that box around the first 2 terms. We want to turn this into a perfect square. So we take the x squared plus 6x and we go x plus 3 squared, right? The 3 is coming from half the 6. Remember, that's going to work because when I expand that back out, I get x squared plus 3x there and 3 more x there. But I've got a problem. I've accidentally added in 3 3's, which is 9. So I don't want them, so I need to take them out. So I've got this plus 8/3, just coming down from here. Sorry, I know that noise is getting up a bit. Never mind. Take away 9 equals 0. So what we're building up to here is solving this equation by completing the square. So just clean up that bit there. There, that can go away. Right, now the next step to do here is this. I'm sure half of you have skipped ahead by now, but hopefully someone's still watching. So there's x plus 3 squared is equal to 9 take away 8/3. So we get x plus 3 squared is equal to 27/3 minus 8, so 19 over 3. I wouldn't be calculating this just yet. I'd try to keep it as a fraction, because if you start to put this in your calculator, you're going to be rounding too early. Never a good thing. So we get x plus 3 is equal to plus or minus the square root of this. And my last step is to subtract 3 from both sides. So that's just a review of how we do completing the square. And now if you chuck that into your calculator, hopefully you'll get the same 2 numbers I got above. So x is equal to negative 5.52 or negative 0.48. So look what we've just done. We've taken our equation and we've solved it by completing the square, right? Even though it had that yucky 3 as the first coefficient. So we've done this by completing the square, and we've also done it using what looks like a magic formula. But of course it's maths, so there's no magic, there's just logic. And what we're going to do now is look at this general quadratic equation, and we're going to very slowly step through all of the completing the square steps, and we're going to end up going from here to this formula here. So let's do it slowly. Now the thing that freaks people out in this is that they get confused about the a, b and the c being just numbers. They're constants, okay? They're no worse than the 3, the 18 and the 8. But we're going to work with this general case. Right, so let's start off. We've got ax squared plus bx plus c is equal to 0. So just imagine that that were a quadratic and you knew what the a, b and c were. Above we had 3x squared. We divided the whole thing through by 3. So here we're going to divide both sides by a. And we get x squared plus b over a x plus c over a is equal to 0 divided by a, so still just a. The next thing we're going to do is box up the part we want to complete the square on. Now we're going to do the completing the square step. So it's just a little bit worse than usual because I've got a b over a here instead of some number like 2. But it's the same principle. So what do? Well, I take the x squared, and that's going to be x plus, well, it needs to be half of b over a. We always have that term. I've still got my plus c over a, but I've got to take out the thing that I've accidentally added in. So in this case, it's not 3 squared, it's a half of b over a squared, which is 1/4 b squared over a squared, which I can write more nicely as simply b squared over 4a squared. So we're going to put that into its own little squiggly box. I'm sure your notes are going to look nicer than this, guys. And now we're going to take that out. So we're going to subtract out b squared over 4a squared, and that all equals 0. So far this is looking absolutely hideous, but a whole lot of good stuff is about to happen. What have I got now? Well, just completing the square bit, we can write a little bit more simply as x plus b over 2a squared. Now, I'm going to do what I did with the numerical example, and I'm going to subtract this from both sides. So what does that give me? Well, it means that I've got b squared over 4a squared minus c over a. Now look at the right hand side. Let's look at this. If we've got one fraction minus another, we typically deal with that by getting a common denominator. And the common denominator is going to be 4a squared, the lowest common multiple of 4a squared and a. Now that's good because that means that my b squared doesn't have to change, right? Because it was b squared minus 4a squared anyway. But what about the c? What do I have to do? It was c divided by a, now it's c over 4a squared. So it's going to be c times 4a, right? Because I've got a and 4a squared. What do I have to do? What do I have to multiply by to get a up to 4a squared? Well, it will be times 4a. So that's doing equivalent fractions from year 9 or even year 7, but with some more abstract numbers. So now we're starting to get somewhere. We've got x plus b over 2a squared is equal to b squared minus 4ac over 4a squared. If we were doing a numerical example, we'd now take the square root of both sides. And we have to have the plus or minus. I'm just about out of time here, but we're nearly done. Because in here, look at what the square root simplifies to. I get b squared minus 4ac here, and then down here, the square root of 4a squared is, wrong pen, just about out of time, over 2a. So that's the part where you might be going, oh yeah, this is kind of cool. The very last thing I've got to do before I run out of time is I have to subtract this number from both sides, and I get x is equal to negative b over 2a plus or minus this, but those denominators happily are the same. So now I can just write it like this. I've got a common denominator, I've got negative b plus or minus the square root of b squared minus 4ac. So there you go, that's your Friday night maths. You're never going to get asked to do that proof directly in an exam situation because that would just be kind of contrived. But the ideas that I've used in there are pretty powerful ones that come up in Excellence at Level 2 and also in the Cambridge AS exam. Thanks for watching. Leave me any feedback in the comments. Aidan, I have used the sparkly pen even more, so I really hope you like it.